Okay, awesome. Hello, everyone.
We're going.
Of course,
Lots of you already
live in
on
YouTube and on Twitch, so welcome to you all. For those of you that this is your first session, welcome. These are a series of interviews that we've been doing throughout that we're going to continue throughout
through the
campaign
campaign
that we're doing this year, where we're chatting to different language creators and core teams, maybe of maintainers of libraries as well, getting a bit of insight into the thought process, the journey. Stream into YouTube, we're available to as well. And there's an opportunity at the end to have your questions put to Louis and do an interview for the first and ask me anything for the second part. But we've got Jonathan, Aaron, Eric all collating questions on YouTube and on Twitch as we go. Feel free to start getting your questions out there now in the chat, and then we can. So, for those of you that don't know, I'm Jeremy Walker. I'm the co-founder and the CEO at Exercism. If you're not, an Exercism free learning platform where learn and improve their programs. Zoom by what part of Exercism, but if not, do sign up and explore it and have fun with it. It's totally free. I also want to just start by saying thank you to everyone that's donated to Exercism as part of 12 in 23. We've had a real uptake since not-for-profit organisation. We really like those. It means the world to us.
by Louis Pilfold,
The creator of Gleam, which is one of the languages around. I'm really excited to have Louis with us. So, hi Louis, how are you doing?
Hey, yeah, I'm really good. I've been using and loving Exercism for many years, since the first version, I think. So it's really cool to be talking to you guys.
Awesome, thank you. I'm told that my internet is lagging, which is just absolutely typical for this. Let me just see if I can reduce the quality. We'll do down to it. Okay. In my
internet connection side. Give me 1 second. Although perfect internet, when you do something like this, and internet just immediately
go. Okay, let's see if this is any better. So we see if the magic of 4G can make this work. So really excited to explore your journey with Gleam, how it came to be, some of the design decisions you've made, specifically around the function elements in alignment with functional February. Also interested in how you see it growing in the future. So let's dive in. Firstly, I'm interested in your background as a person. You know, the run up to you starting to work on Gleam. What was your software journey? How did you become a programmer? Everything around there.
Awesome. I guess I'll start a little bit further back than I usually do when I'm asked about how Gleam started, because, you know, Exercism is about learning to code. So let's talk about that.
Exactly.
So I was doing a biology degree originally, and it turns out I'm not very good at biology. So I sort of stopped doing that, and I wasn't sure what to do. And I'd been fiddling around with computers. In particular, I'd been involved in the open source scene before becoming a programmer, because I was very interested in a piece of open source DJ technology called XWax, which is fantastically fun. Everyone should try DJing. And I sort of realized that if I learned how to code, I could contribute to this amazing program that I had, because it was open source. That was really exciting to me. So I started learning C because it was written in C. Turns out C is quite hard, and then I sort of backed off a bit, and then I sort of yeah, exactly. And then I found you know, there's a great world of resources online to learn to code. So I didn't find Exercism straight away. I found like edX and Coursera, I think, those sort of things, where you could do like the MIT and Harvard undergrad courses, you know, at your own pace online, which was fantastic. And I very quickly got the bug and sort of burrowed away from there. In theory, I'm going to write that DJ software, but I haven't got around to it yet, and it's been north of a decade now, so there might be some time.
Unlikely to happen.
Yeah, I'm sure it will happen. You know, I've just got to finish my to-do list first.
Yeah.
As for Gleam, how did Gleam start? So I, probably like many people on Exercism, love programming languages. They're really fun. It's really fun to like pick up a new one, start learning it and go, oh, what makes this different to the languages that I already know? Or like, what's good here? And what's not so good here? And what can I learn from? And what new techniques can I learn? Because I think that makes you a better programmer, as well as it being really fun. And so I would learn, try and learn a language or two every year. And I got to this really weird point where every language I was using, I kind of wish I was using a different one. So I really love Erlang and Elixir. They're really great at like doing multi-core stuff and fault tolerance and all this sort of really great stuff. But whenever I was writing them, I really wish was writing like OCaml or Elm or something, because I really missed all those type system features. And when I was writing OCaml, I was like, oh man, I really wish I had like the actor model, and I really wish I had these other things. And so I eventually started thinking, so what would my ideal language look like? You know, if I could steal all my favorite bits from all these good places and try to piece them together in a cohesive way, what would that feel like? And then I just sort of started experimenting. And as much of a surprise to me as anyone else, really, it sort of coalesced into something which, turned out not to be just a little hobby project, actually turned out to be quite useful. And for the last few years, I've been, focusing on it very heavily, trying to make it something which can be, really valuable to people, I hope.
So what is it that you feel like makes Gleam? What are you say picking those different bits that you like from different places? What's the unique thread? What's the thing that brings everything together in Gleam?
So it's tricky, really. So I think a lot of languages, or when you see new languages, always try and explore some new exciting thing. Like we've got this new technique or technology or piece of computer science. Like how far can we take that? And you end up with sometimes really exciting things happen. Like Idris is a language exploring dependent types, and there's clearly some really exciting things there that I think in 10 years' time, a lot of languages will have things from Idris in it. But a more today example is Rust. Rust started as this sort of niche little hobby project where they're experimenting with, what if we use linear types in a programming language? What could we do with that? And suddenly we've got this whole new way of working with memory. And it is apparently the most popular language or most loved language on the planet, according to Stack Overflow, which is wild. And Gleam's not doing any of that. Like Gleam's not trying to explore a big new thing. The type system is very much from the 90s in a good way. We've taken, I think, the best one from the 90s, but it is, it's well understood, well proven technology. And the thing that makes it good, I know, is the way we have picked things to be cohesive, to fit together really well. So rather than before adding anything, we've got to think not just about what it enables, but actually how it sits with all the other pieces. And anytime we're going to be adding something, we've got to think very carefully about, okay, so what does this solve? It allows us to do A and B, but it doesn't allow us to do C and D. What would the thing look like enable us to do all of those things? Because the general philosophy and idea is that if we have a language that is fun and practical and very capable, but also has a very small surface area and is very consistent and cohesive, you'll be able to learn that and get productive and make things much faster than you would be able to otherwise. So as much as I love learning things, we want the learning process to be really quick so you can get through that really easily and then get to the good bit of making stuff. Because that's kind of the point.
So for those people that aren't,
and there are other languages that.
Sorry, you go on. I'm still lagging here. Sorry.
I was just saying, it's not an original idea. There's lots of other languages that are quite similar, like Elm and Lua and Go. But I think I think we've taken it in a bit of a spin that none of those ones have done, because we're general purpose and we're functional, and I hope we can be a lot more. I hope we can be as practical while also meeting a different set of desires and needs and niches than those languages can.
So for people who aren't familiar with Gleam at all, they maybe not even looked at it yet, can you introduce the language a little bit? Obviously, it's a functional language. It's on the Beam. Is it the Beam or Beam? I don't know. On the Beam. But yeah, just introduce it into people. Just a few of those core things that make it Gleam.
Sure thing. I normally go for the Beam.
Okay.
I don't know. I don't know if I can speak with authority, but there we go. If we're both consistent within this call, then we sound like we know what we're doing. So the key points are, being functional is really important, as you said. I personally believe that functional programming is just sort of inherently simpler than, for example, object-oriented programming. If you just think if your program is a series of boxes, something goes in, something comes out. That's easier to think about than objects and inheritance and contravariance and covariance and all these things that come up in the object-oriented world. So that's my theory. And simplicity is something I'm very interested in. Another thing that it's very good at is the idea of having the computer try and help you as much as possible. The general idea is that, there's lots of things that people are not particularly good at that computers are really good at. So an example of this, you might change the name of a function or field in your program. It's really hard to remember where every place you use that function is. Especially if it's an older code base, the one's been around for years. But it's actually really easy for a computer to find those, providing that the language has been designed to do that. And that, this is something that's very difficult in some languages and very easy in others. So Gleam always makes the decision to try and make it easier for the computer to learn things about your code. And because it learns more about your code, it can do lots of things that other languages cannot, is the general idea. And this mostly comes from static analysis and particular type system, very much in the style of languages like OCaml, Elm, F#, PureScript, Haskell, to some degree Rust, that sort of thing. So that's the side that's really exciting. But there are lots of languages that do already do those things. So why would I want Gleam, especially since OCaml and F# are also quite simple and quite cohesive and easy to learn? Well, that's where the other side comes in, I think. So that's sort of what happens at compile time. But there's also this whole other time, when your code is running and being used by users. And that is where the power of the Erlang ecosystem, the Erlang virtual machine that Gleam builds off of and runs on, comes into it. So I think that the Beam is really interesting. It's quite rare, I think, for a functional runtime. Well, it's quite rare in that it is a functional runtime. That's weird. Most languages most runtimes, like the Java virtual machine and things like that, they're designed for procedural or object-oriented languages. And then we put functional stuff on top. Well, that's not how the Beam works. It is for a functional language, and it is functional all the way down, which means it can do a bunch of cool optimizations that other ones are not able to do. Everything's immutable. Immutability is really cool. It makes programming easier, makes a lot of programs a lot faster. And because everything's immutable, the garbage collection can be tailored towards managing data in that way. That's really exciting. But the thing I think is most exciting about the Beam is that when they were making it, they were not trying to meet some academic need, as with a lot of functional things, or they weren't trying to do a pet project. They were trying to solve real-world problems back in the 80s and 90s. And the real-world problem they were trying to solve, which was super niche, really unusual, is firmware for telephone switches. Now, telephone switches are really odd because they've got to be super low latency, super reliable, connected to the network all the time. They've got to be able to withstand faults. What happens if your computer is on a telephone box and a telephone pole, and the telephone pole gets struck by a bolt of lightning? Okay, how does your system keep working in that case? These are really interesting problems. And so they built a system that is capable of handling all these things, and they baked all these things in the runtime for you to be able to survive and perform well and debug running systems. And it turns out what was a really niche problem in the 80s of these like super networked, low latency, high concurrency systems is just the norm now. You know, thanks to the rise of the internet, almost all programs need those properties. And thanks to computers having multiple cores, with you know, suddenly being able to do things concurrently and do things in parallel is so much more important. And things that are quite difficult in other languages, say ones running on the Java virtual machine, are super easy on the Beam. So that's really cool.
Nice. Where do you see yourself fitting into that ecosystem of Beam languages then? Because obviously, as you said at the start, things like Elixir out there, Erlang as well, obviously. Is there a niche that you're trying to fill? Do you see yourself as like interacting with those other languages?
Totally. So I think it's really important to think a lot about the ecosystem that you're slotting into, because, you know, I'm a huge fan of the Beam ecosystem. I've been a member for a long time, and I don't want to make something that is about, you know, competing with other members of the ecosystem. I don't want to be like stealing Erlang developers or anything silly like that, because you know, first off, I don't think it's very nice, but it's also not very productive. You know, rather than like fighting over this existing pie, we want to be growing the pie. What we really want to be is bringing more people into the Erlang ecosystem, into this ecosystem that I think is really fun to work in. And the more people we have in it, the more things we can make, and the better we can enjoy it, and all that sort of stuff. And so I think that's why the design of the language that Gleam has gives it certain advantages here. So Erlang and Elixir and Gleam are all functional programming languages, and when they are running, they're all very similar. They can all call into each other with zero overhead. They all have the same representation of functions and data structure and all this sort of stuff. So if you look at it just like that, it seems a bit pointless. But because Gleam has this whole static layer, this layer of a type system and static analysis on top, the experience of writing Gleam code ends up being very different to the experience of writing Elixir code or writing Erlang code. And so I think from experience, there's a lot of people who have said, oh, this Beam thing sounds really cool. I like the idea of having this like super concurrent, fault tolerant system, but I don't really enjoy Elixir and I don't really enjoy Erlang because I miss having types, or I miss having you know, various other static analysis-based features. And before they just go, oh, well, that's a shame. I'll just go back to, you know, something else, whatever I might be writing otherwise. But now those people can go, oh, I'm really interested in that runtime. Oh, look, and there's a language which has the programming style that I'm a fan of. And so I really think it's about enriching the ecosystem with another way of doing things. We've got the dynamic type stuff down, so let's get the static type down.
And what problems do you see being solved in Gleam, or what applications might you use Gleam for rather than, you know, Elixir or something else? Or is it simply you might do the same thing with it, but it might be a you know, a different way of programming, you know, as you said, with type systems and things in there?
So I think if you're comparing it to Erlang, and you know, Gleam and Erlang are both general purpose programming languages. You could choose to do pretty much anything you want in them. But they've got strengths, and Erlang's strengths are definitely networked applications. Like people really like to use Erlang to write web servers and web APIs and databases and message brokers and queues and this sort of thing. And I really do think that Gleam would meet exactly the same niche, as it were. I think it really is, as you said, like the main thing is just about how is it that you want to build that system? What kind of experience does you and your team want to have when they're building something there? Now, Elixir is a little bit different because, like I would have previously said, Elixir and Erlang both have the same thing as Gleam. But in the last few years, Elixir's had a few really exciting expansions in which they've also become really good at machine learning, which is you know, mind-blowing. Really, they've done some really impressive stuff. So we've got a little bit of catching up to do for Elixir if you want machine learning, but maybe we'll get there.
How much can languages like interop on the Beam? Could you like NX, which is the Elixir stuff for that? Could you sort of bring those libraries into Gleam? I don't know Beam at all. How does that work?
So Elixir's magic really is its macro system. So it's a functional programming language that runs on the Beam. It has sort of Ruby-like syntax, but it has this other thing which is sort of like secretly taken from the Lisp world and you know, tricked everyone into they tricked everyone into writing Lisp, but without all the scary parens and stuff, which I think is brilliant, really. And it means they can expand the language in ways that other languages cannot. They can make things that feel like part of the language, but purely by writing regular Elixir code. And that is what this new sort of mathematical computing stuff in Elixir is about. It uses macros to take, you write Elixir code, and then it will compile it rather into Erlang bytecode. The bits that you're interested in, it will compile that into code that runs on the GPU, for example, or something else. And suddenly, all these things that would have been really comparatively slow on the Beam are really fast because you can do it hyper-parallel fashion on a GPU. So there's a problem here in that you know, we try and have as good interop as possible between Beam languages, and generally we do pretty well with Erlang, Elixir, and Gleam. But in this case, we can't do it because Elixir is the only language that has this macro system. So it's not as good as I'd like to be, but there is still benefits. The Gleam build tool, you know, we care an awful lot about interop, and as such, the Gleam build tool can build Gleam, obviously, but it can also compile Erlang and Elixir. So if you were to write a Gleam program that wanted to do some of this numeric computation, you could have most of your program in Gleam, and then you could have one or two or however many modules written in Elixir that uses this new feature. And then you can just call the Elixir code from Gleam like a normal function, but you have to use the macros in Elixir itself.
Someone asked the question, how easy is it to work with Gleam and Elixir in the same project? I guess that pretty much answers that, but you know, can you just have and some Gleam files and, as you say, just have a couple of different modules and the compilation process sorts it out?
Yeah, it depends which build tool you're using. So each language has their own recommended build tool. The official Erlang one is called Rebar. The Elixir one is called Mix, and the Gleam one is called Gleam. Very creative. The Gleam one, probably because we're the newest, we support all of the languages. You know, we can compile Gleam, we can compile Elixir, we can compile Erlang. The other two languages, their build tools don't know how to compile Gleam. So if you're writing Erlang and you're using Rebar, you're kind of stuffed, really. There isn't an easy way for you to seamlessly use Gleam code. You're going to have to, you know, perhaps use the hooks feature of Rebar to do a little bit of extra compilation, or maybe use a makefile or something like that. So you're going to have to do a little bit of glue. If you're using Mix, there's a really fantastic project made by the Gleam core team, which sort of is a best effort approach at hacking Gleam support into Mix using their plugin system. And it works pretty well, but it's not as seamless an experience as you would get with using the Gleam build tool. Just because, you know, in the Gleam build tool, we can change anything we want, but in the Mix one, we are using public APIs and also being a bit naughty and using some private ones that we shouldn't. But we still can't change actually how the build tool works. So sort of. Yeah.
And I know things like error messages are like really important to you and an important part of like how you thought about the language. We're building this, I think I mentioned in the JZ1, a new programming language as well for Learn to Code at the moment, which I think you know about a bit. But, you know, actually not the whole, but a really strong part of that for us is around that error message and providing them to, especially total newbie coders. I know that's something I think you're maybe proud of in Gleam. Do you want to talk a little bit about that and what that's looked like for you?
For sure. And I think we should give credit to Elm, because I think Elm is the language that really kicked off this, you know, this more recent wave of really improving error messages. And it's probably done more good than any piece of advancement in
Nice.
you know, practical engineering.
Mhm.
So yeah, well done to them. And it is something that I think is quite tricky to retrofit, or with certain language designs, it's really difficult, you know. If you've got a very dynamic language, as I was saying before, the compiler doesn't know as much about the program itself. And that means that when things go wrong, there's much less information for you to try and reconstruct what has happened and say, okay, well, you know, how do I explain to the user what's gone wrong in a way that's easy to understand? So we're very lucky in the Gleam world that, you know, first off, this was a constraint from day one. We were like, we want to have really good error messages. That's super important. But also because the whole language and compiler is designed to gather as much information as possible, we can then use that to inform you. And I kind of feel like the Gleam error messages are nowhere near as good as I want them to be. And I think we're only just scratching the surface of how good they are, but people still love them and they're still better than most languages. So I think that's a really good sign. Like, we've got something that is working, people like, but we could go so much further. Just need to pour more time into it, really.
And have those, do you feel like thinking about things like good error messages almost as like a first-class citizen, is that affecting the language design? Like, are you limited or thinking about syntax based on that?
Yeah, totally. We're quite lucky in that all the error stuff and the static analysis stuff sort of all moves in the same direction. So, you know, there's not friction. We don't have a friction of, hey, we want to have really good error messages, but on the flip side, we want the programmer to do, I don't know, for example, runtime metaprogramming or this or that, or all these things that make it really hard. So it's all moving in the same direction. So that makes it a lot easier. But we do need to think a lot about, okay, how do we, you know, how are we going to deliver, you know, if you're going to add something to the language, and say you've got a set of tick boxes, maybe it'll be like, oh, it's got to have a nice syntax, it has to be fast, you've got to have unit tests for it in the compiler, all this stuff. It has to have a really nice error message when it goes wrong, and it will go wrong. How are people going to use it, and how are people going to misuse it, and how do we let them know what's going wrong? So that's part of the language design as well, and it really fits into how we build the compiler. We end up passing around loads of extra information that isn't really useful, really. If you think as a compiler, a thing that compiles code, kind of pointless information, but we carry it around anyway, because when it goes wrong, suddenly it becomes really useful. And I read embarrassing, I've forgotten who it was now, but I think someone in the Rust world, maybe a Rust core dev, I'm not sure, said that a compiler is a program that turns source code into error messages, and as a side effect, it may also produce some executable code. It's like, yeah, I like that. That's actually the thing you want to be thinking about most. There's another factor to it though. Like, you know, another thing that I wish I thought of earlier, and that is the idea of interactively working with code. So we have started about a year ago, I believe, offering a language server. And so what that means is that if you have your editor, say Visual Studio Code, or I was going to say Atom, but that doesn't exist anymore.
No,
Vim,
old school.
Rip Atom, Emacs, or whatever you have, rather than each one of them implementing all these IDE features like error detection and refactorings and all this sort of stuff, go to definition, etc. This language server will surface those to the editor, and the editor just makes API calls into the language server in order to do whatever the thing it needs to do. That wasn't something I considered from the beginning. And this means that I've got this really irritating problem in that the compiler is designed to take source code and go to either having a working running program or having an error and then stopping. That's not how an editor works, because really you want to go to, oh, something's gone wrong. Well, let's keep going so we can learn as much about the program as possible. And I can say, well, there's errors here, here, and here, but all these bits are correct. So if you do anything in these bits, I should be able to give you all the type information. But currently the language server for Gleam says, oh, you've got a type error, and in function 1, and now I can't tell you anything about function 2 anymore. Which is rubbish.
Yeah.
So now I've got to I've got to like, yeah. So lots of things are happening behind the scenes to fix this problem, but I really wish someone had told me about it 4 years ago.
One of the things that we've been thinking about a lot when thinking about teaching total newbies to code is the vast amount of different types of errors that you get. And the reason that we want to do this is we don't want to give better error messages about like your code not working. We want to give better error messages about you not understanding code properly. And it's like quite a different conceptual thing. But like you said, if you are only like looking after the fact, so at Exercism, as you know, like we've got analyzers and representers that analyze the ASTs of every solution that's submitted, and then try and give feedback based on those. But you're so after the fact at that stage that although you can do lots with it, and there's lots of amazing stuff that the track maintainers have built, still it feels like you're missing so much data. And for us thinking about, okay, how do we actually understand if someone's making a conceptual mistake? Actually, that's happening almost before like the tokenization process. It's not that it's somebody's not indentation, like someone's not indenting their code properly, and that's going to lead to a misunderstanding of what's happening. And so we've been trying to think about, can we do that with existing languages? How do we retrofit that? And the conclusion was retrofitting that is actually a lot harder than just building our own language and building this stuff in from day one. So that's been a really interesting part of that journey. So I can really, we're a lot earlier on that journey. And the other thing I was going to say was, Exercism's editor has language server support built in, and we actually prototyped this a while back, but we've not deployed it, and we've not had anyone that's had time to like properly do the language server stuff. So that could be a fun little project, because we've got all of the backend infrastructure and everything ready to go, but just never flip the switch. So we could prototype that with Gleam and have that as a bit of a showcase. So maybe something to pick up with Eric afterwards.
That's super exciting. We could probably doesn't fit in with your infrastructure, but Gleam can actually run the compiler inside a web browser, because you can compile the compiler to Wasm, and we've got there is an existing Gleam editor environment where everything runs inside the browser. Mostly because I didn't want to run a whole fleet of servers like you guys do.
I mean, Wasm's a big part of how I see our future. Just from a cost performance, it gives us infinite scalability. The challenge with Wasm, so for people watching this that don't know, most languages now you can actually run natively in the browser, in the same way that you run JavaScript, and you do it through this thing called WebAssembly. But the problem is that you have to download effectively the runtime for that language into your browser, which it's not huge on I feel ironic saying this, it's not huge on a modern internet connection. I've struggled to stream a basic video for the last 40 minutes, but it's like 10, 15 meg or something. It's of that region. For us, one of the problems is that actually closes off Exercism to a huge proportion of the world who 15 meg is expensive, it's time consuming. And so we would love to have Wasm there, because one, it means that you're going to get a lot quicker response times. You don't have to go through the server cycle for us to get that back. But we can't just have that as our only option. So, but yeah, one of the things I know Sleepless Bite, Dirk-Jan, has really wanted to just find a month to prototype this, but is just taking some of the stuff we've got and choosing a couple of languages and prototyping those in Wasm as well. So maybe that's another fun thing. I know Bobby Towers has just got some funding from Closurists Together, I think, to work on the Closure track full time for the next 3 months. I know she's looking to do language server support, I think, for Closure and some stuff in there. So that might be another fun project as well, that we can see if there's any other maintainers that want to jump on. But could be a nice little improvement that we could do there. Somebody else asked in the chat which language has the best error messages that you're modeling off. I mean, Rust as well. Are there any others that have been sort of inspirational to you as you've gone through?
I think the real winners are Rust and Elm, but they both annoy me in different ways. Okay. So I think we're getting into the point with error messages where they're so good, we're starting to get into personal tastes in the same way you get with syntaxes now. Lots of people are like, oh, well, this language has such an elegant syntax. And I was like, no, that one's awful. This other one's got such a beautiful syntax. And I look at them like, they both look fine. I don't care. But I think I'm much more polarized in error messages. I think they both have a problem in which they can throw really nice error messages at you, but a lot of them.
Yeah.
Like it can very easily throw out thousands of lines of stuff. And the formatting of the Rust ones is, I think, pretty verbose. So something I want to explore, something that we do accidentally because of the limitations of the compiler design, as I have previously explained. We don't show you lots of errors, we show you a very small number. Yeah. And I think even when we lift that technical restriction, I think we're going to deliberately constrain it. So when a fault happens, we try and identify which are the ones that really matter, or rather we will compile in a staged fashion so that we know where the root of the problem is going to be. And then we only show you things from that area. I think that's going to be the way. And then you'll just have less to look through, and it should be a bit easier to progress there.
Yeah, it's a similar thing to what we do in the online editor for test failures, where we will only show you that first test, even though there might be 100 tests failing. Rather than overwhelming someone, it's taking a test-driven development approach. But I do think almost taking that, there's pros and cons, but taking that to the language level where it's almost test-driven design, but at a compilation stage where you're just showing that first major. I always think it's what's the major thing I need to do to make the program correct or to move forward? If you're just thinking that thing one step at a time, I feel like you can get to a good place a lot quicker than just, as you say, being hit in the face with a load of information.
Totally, and I think TDD is a really good thing to call out. I think that for me at least, a lot of those methods and ideas in TDD of we break it all into a series of steps, and I solved one step, that was really easily. I solved the next step, that was really easy. I solved the next step really easy. And then 200 steps later, oh look, I've solved a measurable problem. How did I do that?
Yeah,
that experience is so powerful. So if we can automate the creation of the steps, with static analysis, language design, excellent tooling, that sort of thing, then I think we should lower the barrier to a lot of programming problems. I really want to make a language, and it sounds like you are as well, in which people can solve problems they wouldn't be able to do in other environments. That is fundamentally the whole point.
Nice. And you also, I think, have said to me before that it compiles down to JavaScript itself. I'm interested in both the rationale for that decision and the use cases for it.
So from a quite selfish point of view, it's again that whole thing of when I'm writing one other language, I really wish I was writing this other one. And Gleam's trying to meet this need of for me personally, just do all the things I want it to do. And it's all very well and good having something that runs on this virtual machine, and it's not as heavyweight, for example, as the JVM. It boots a lot faster and you can run it a lot more places, but it's still quite limiting having this whole virtual machine thing to lug around. So you can practically run it on servers, or if your users are like you a lot, they will go for a slightly awkward install process to get your software running on their personal computer. But if you want to run it on a mobile phone or on a CDN or any one of these places, or in a web browser, that's the really obvious one, you're stuffed. So you need something else. And we've mentioned Wasm. It's been a really good solution for these things. But really the universal language of today is JavaScript. That runs absolutely everywhere. And I think Wasm is probably going to muscle in on that space. But for today it's JavaScript. And with the way that the Gleam compiler is built, it's relatively easy to add a new high-level target. So in this case JavaScript. And it all been something I was quite interested in because as I said, it's being quite selfish with this feature. But then one of our early power users, a chap who started his own Y Combinator funded startup purely in Gleam, which I was absolutely baffled by. And then it went bankrupt. I'm pretty sure that's not because of the Gleam. I think that's something else, but I've not asked him. He said, "Oh, I have a need. I need to do front end stuff, but I want to do it in Gleam because all my other stuff." So he just sort of turned up one day with a mostly working new backend for the compiler and went, "Oh wow, that's something I was gonna do at some point. Okay, let's polish it up. You've got a real life need for this thing. Let's get it out the door. And I always imagined it would be, that sort of situation that I hypothetically was going to be in, and Peter was in this case, where, we're Gleam programmers. We use Gleam on the server, and we want to do a bit of front end stuff, or we want to do a bit of mobile phone stuff, or we want to do a bit of edge function stuff. And so that seemed like a good fit. But I've been really surprised, because there are lots of people who just use the JavaScript backend, which it seems like a harder value proposition to me. If you say, it's a function, well-typed functional language that runs on JavaScript, you go, okay, but why wouldn't I use Elm? Or why wouldn't I use PureScript? Or why wouldn't I use Reason? Or why wouldn't I use Rescript? Or there's a lot of or F# with Fable, or there's loads of different ones. And so I was like, I don't know how to answer that question. I think it's nicer, maybe, for some people, but it's a lot harder to argue that. But some people are going for it, so we must be doing something right. I'm very happy.
The last two answers you've given have got me thinking a little bit about the process that you've gone through in building Gleam as well. So you talked about this idea of chipping away at hundreds of tasks, and eventually you can sit back and say, look at what I built. I imagine that's been a degree of the journey with Gleam. Like, how much of that did you set out with this is the plan for what I imagine Gleam 1.0 is going to look like, or how much was it just like, I'm going to start just knocking some features out and evolve it? How much planning was there? How many has it been? Lots of little stages? What's that journey look like for you?
It's been loads of little stages, but I've got a trick. I've got a secret piece of advice for everyone who wants to make a language, and that is delay making the language for as long as possible. And when I say that to people who make languages, they're like, well, the fun bit is making the language. I want to make the compiler. I like that bit. No. I think what you should do is you should write as much code in your language as possible. You don't have any way of running it. You don't have an interpreter. You don't have a compiler, but just write programs. What would a web server look like? What would, pick any app and try and implement it, and then slowly try and interpret it in your brain. So what would that would do this, and this would do that. Okay, how would I compile it? I want this feature to work. How would it know all the things it needs to know inside the compiler? And it's, slow and laborious, and you don't actually get to do anything at the end of it. But you uncover loads of things that you would have previously only uncovered about all these features that you've put together, after you spent weeks and weeks and weeks implementing the things. And you go, I've got a new idea for a feature. Okay, well, I just write a load of programs with it immediately. And then, it clearly doesn't work because of this case I found. Okay, well, you spent an evening, thinking really hard, but then you've just dodged implementing a feature for a week. So that's the secret. But even if you do that, it's still a huge job making a language. It's people often say to me, "Oh, that's amazing! You've made a language. You've got to be really amazing at computer science." And don't get me wrong, there's a bunch of theory involved, but that isn't really the hard bit, I don't think. I think the hard bit is just being stubborn enough to just keep doing this for years and years and years. The Gleam code repository is about 5 years old, I think, like the active part of it. So you can sort of get an idea how long that part of the project's been going, and I've been working on it pretty constantly during that time. But even before that, there's a bunch of prototype repos that I've lost, and there's conference talks, and there's experiments and books and all these sort of things. So it stretches on for a long time.
You before this, we were talking about an up-to-date photo to use on like the YouTube thing, and I used a photo from you at a conference that I think you were like, you can't use that, I look too young, but you can almost see like the journey that you've been on through creating Gleam. I know recently the point where you're now able to work full-time on Gleam. You've got is that through like just individual sponsors? What's been that sort of milestone that's enabled you to do that?
So I'm super lucky that I can do this, and it's a real dream to have a bunch of people believe in this thing as much as I do, and want to put their money where my mouth is. It's very Very kind of them. So so the GitHub sponsors program came about, which you're probably familiar with, and somebody said you should sign up to this because you do lots of open source. You're doing this cool, I maintained a bunch of tools in the Elixir space, and I was working on Gleam. Okay, you should do this. And I was like, oh, sure, why not? I might get enough money for a beer or something at the end of the week. And people slowly started to contribute, and it just kept growing, and it became a noticeable part of my income, which I found stunning and really humbling, and really gave me a lot of confidence and reassurance in the decisions I was making. And then one day, Fly, the sort of deployment platform, they started sponsoring as well, and I was being a corporation rather than people, they sponsored a lot more. And it got to the point where it got to this point fairly recently where it wasn't such an amount of money where it would be like the same salary I'd have if I was working as a software engineer at a company or something like that. But it was a reasonable amount of money to live on. And I'm lucky I don't have any particular big expenses. I don't have dependents to look after or anything like that. And as such, I can take a bit of a risk and earn less and live the dream and build my thing. So I feel super lucky. And I've taken a risk and worked on the thing without a job before, and it just means I get poorer for a while, and then I get to a point like, oh, I've got bills next month. Oh, I really need some money. Then I phone up all my friends and go, hey, you looking for an engineer? We've got a long quote well before. Can I start next month? Because I really need money, please. So I've done that a few times. But yeah, now it is an amount of money where I can live on, and that is amazing.
Yeah.
And if anyone else wants to contribute to that, you can get on sponsors.
Please do split your contributions with Exercism. I have to say that at that point. But no, 100%. I mean, it's this, similar challenges that Exercism face. I put it out in the video yesterday. We turn the servers off at the end of this year unless we get some sponsors. It's a real thing. We've got a team of 5 full-time people now, six in total in the team, and it feels like 6 times harder to almost hit that target. It's amazingly exciting when it happens. Like, we had a big uptick in donations in January and February, and that really felt encouraging. And it was like, okay, maybe we can do this. But if you'd asked me in December, I was like, this feels really hard. I was feeling so. I think it's a massive achievement for you to have got there. So congratulations. And I think once you've got to that point, now you can, as Gleam, more people use it. Hopefully you can build on that. And it feels super exciting.
I do feel the fear as well, as you do, so and also congratulations to you guys. You've got you've got real costs of like five people and, a whole ton of servers running everyone's tests and stuff like that. It's a lot more than my free tier of GitHub Actions and me trying to, me buying soup. That's sort of all I've got really. But I do feel nervous that everyone is going to collectively go, oh, actually, I don't want to. I'm bored of this now, or it's not going fast enough, or Fly. They are just, they are the biggest sponsor. And so while I wouldn't be completely stuffed if they left, if they did leave, I would feel uncomfortable. So I would love to get some more companies sponsoring as well. But it's sort of, in a way, it makes me very nervous in the way that, like, what I do doesn't have a direct relationship with how much money I've got in. It's just sort of, I don't have a contract with these people. They haven't said, well, if you make it do this, I'll give you this much money. It is literally just vibes, I guess. They sort of like it. And that is both terrifying and freeing at the same time. I am free to do whatever I think is the right thing to do for the project. And at the same time, I just have to hope that they agree with me. And that's okay.
Yeah. So a couple of questions around the decisions you made around choosing it. So I believe you wrote Gleam in Rust. Reason for that decision? Regrets? Happiness?
The reason is that the first version, well, depends how far back you want to go, really. But the first real version of the compiler was written in Erlang.
Okay.
Because it runs on the Erlang virtual machine. That makes sense. We can bootstrap it. People can contribute to it easier. Blah 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 blah. But I got to a point, and this is to some degree because it's also it was a learning experience, writing a big, really big, proper full language compiler for the first time. I got to a point where I realized I'd made a really big mistake in the type inference algorithm. A mistake where I'm going to need to refactor the whole thing like really very aggressively.
Wow.
And it will also like spill out onto like the AST and all these other places as well. And I looked at it and I thought, I just don't know if I'm actually going to be able to do this refactoring. It's going to be really hard, and dynamically typed languages don't offer you much help. I mean, Erlang is pretty good for this dynamically typed language. It's much easier than, say, a JavaScript or something, but there's a limit to how good it can get. And so I was like, okay, I've accrued enough tech debt in this first iteration of the compiler, and I've got a huge problem. Is it easier for me to just start again from scratch with the lessons I've learned and then get to the same point and be in a much better place going forwards? And I afterwards decided, yes, that a rewrite was the right thing to do, which luckily turned out to be correct. But I also had this weird situation in which I thought, well, I could choose another language now. There's no reason why, if I'm doing a full rewrite, I need to use the same one. And I said before about Erlang being really good at these networked, hyper-concurrent, fault-tolerant, blah, blah, blah things. None of these are a compiler. A compiler doesn't do anything like that whatsoever. So I was, there are benefits to it, but I kind of wasn't using something where it's optimized for it. And there is another family of languages that I love dearly that are really good at that. And that is the ML family, like Haskell and Elm and all these sorts of things. And so I thought, well, maybe that's it. Maybe I want to have all this like static analysis to really enable me to really rapidly, not just rapidly write the code, but rapidly change code that has already been written. And so I drew up all the pros and cons, and I ended up sort of trying to decide between Rust and OCaml as like two very much dearly loved languages. And I went with Rust in the end. I think mainly because I thought that, Rust was really getting started, really getting started at that point. I was like, okay, well, if I'm going to become an expert Rust or OCaml programmer at this point, when this whole thing collapses and I need to get a job, I think I should probably bet on the one where I think there's going to be more jobs. And I think it would have gone really well in OCaml, but I'm really happy with the Rust choice. Refactorings that in the Erlang one would have been terrifying are now trivial. I sort of watch the TV and I just changed the name of this thing or change its data structure. And I'm like half watching, there's another type error, fix it. There's another type error, fix it. And I just keep doing that. And then at the end it works. And it's just magical. It's such a nice experience. So that has been really valuable. It's also really fast. Have you seen how fast Rust is? It's bonkers. It's just so fast.
Yeah. We're featuring some systems languages next month for Mechanical March. So we've got like Go, Nim, Rust, and then obviously C, C++, D, even Zig, V. Like it's interesting just how fast they are and compare those features. I think. But yeah, I mean, Rust is so loved for those two things: the speed and then the fact that once it compiles, it seems to work most of the time. That's the big selling point.
The flip side is that that those first few months is like running to a brick wall. Like it's a lot better these days. They've really improved a lot of things like error messages and the ownership checker system. The borrow checker is much easier to work with than it used to be, but like, it's still pretty hard to learn. And there was just lots of points just like, I just feel too stupid for this language.
I think a lot of people say that. I think we've struggled with that even with our the syllabus on Exercism, because I feel like the people who have contributed Rust exercises tend to be really experienced Rust developers. And I think I have strong feelings about this in programming in general, but I think there's a lot of survival where people who are either really, really smart or have just really clicked a few concepts at a certain point. It might be they really like maths and then they were taught programming in a mathsy way. And it's those people tend to be the people that write a lot of the educational content and stuff out there. And I think that then excludes people that either are not, Einstein level smart, or are not, or haven't been introduced to programming in the way that just clicks with them. And I think that's been a challenge, especially with something like Rust, where it feels really esoteric. It feels like there's only a small group of people can possibly work it out. And then almost like the content that comes out of that means that it's even less approachable. So I really want to, at some point, just do like a deep dive in making a syllabus on Exercism that is just like so trivial for anyone to learn Rust, even though the end goal does feel hard. Because I think there are so many failure points in there where it does just hurt if you can't work something out. Running into a brick wall is a good analogy for it. I mean, on that, go.
I think there's even like another thing that makes it slightly harder for Rust is that I think that the way you would teach Rust to people will vary wildly depending on what their background is.
Yeah.
There's new concepts to everyone in Rust, but the question is, which ones are the new concepts to you? Like, if you are the Haskell person, you will know a lot about the trait system and the static analysis of Rust. If you are a C or a C++ person, you're going to know a lot about ownership. So you probably understand the rules that are encoded into the Rust type system. If you're a dynamic, a scripting language sort of person, you're probably going to be really familiar with a lot of the tooling and the libraries and stuff like that in Rust. So, like, which thing do you focus on? Like, they are completely exclusive. You almost at the beginning of a Rust course need to go, so what have you done before? Does this word make sense to you?
And this is a massive challenge that we just face in Exercism in general as well. If you've done functional programming before and you then do the Elixir track, the exercises you need are totally different to if you've not done functional programming before. And because everyone's journey is different, like, unless most programmers have dabbled in a few things, they've picked up some different things. It's really hard to know how to pitch anything. And you don't just want to let people skip things, which is where we originally started, because often you find there's just then holes in knowledge later on that then just means the whole tower mental like model falls apart. And I strongly believe that when learning programming languages, there's a really big skill in unlearning what you've previously learned. You have to almost set your brain back to zero every time and be like, okay, I'm going to learn the trait system in Rust, and I'm not going to, it might be easy for me to learn because I've done it in Haskell before, but I'm actually just going to still learn it from zero as if I didn't know it. And one of the things that Katrina and I have talked about a lot over the years and wrestle with is and where I'd love to get to is almost having like canonical pages that explain every concept. So this is, higher order functions as a page, standalone thing. And then when you are learning Elixir, it's like, we presume you know what higher order functions are, and here are higher order functions in Elixir. If you don't, here's a really wonderful tutorial on them. And that's sort of the vision for how I see the concepts and the syllabuses long-term fitting together. Which brings me on to something I've seen on the Gleam website, which I loved, which were your cheat sheets, which got me super excited because I now want to do like a cheat sheet for every pair of languages in the whole world. And I said this to Eric this morning, and he says, this sounds like you're going to make a lot of work for me. But I really love the idea that we like have the same snippet of code in every single language in Exercism, and then you can just compare two languages, like show me this in this. And if you haven't, people watching this, if you haven't like looked at Gleam's cheat sheets yet, they're brilliant. Go and look at them. But it just says this is a function in Gleam, this is what the equivalent Elixir code would look like, or this is whatever in Gleam, this is what the equivalent of Elixir code would look like. So one, like, what inspired you to do those? Has that been a community effort, or has that been you? Like, just really impressed and interested in that journey.
Whose idea was that? Oh, I feel terrible.
You're gonna have to put it in the comments afterwards.
Someone came up with that, and for the life of me, I can't remember. Was it me?
Take the credit. To be me. Maybe it was you when you were asleep in a dream or something.
Somebody's idea that was. I don't know. That's really annoying. I wish I could remember. Oh, it might be the Elixir team. I think there might be a not particularly advertised, unloved Erlang Elixir cheat sheet somewhere on the Elixir website. That might be where I stole it from, and I thought that was such a great idea.
Yeah,
that
fantastic.
because there's loads of people who are you know, and we've got a real advantage in Gleam because like it's meant to be really simple, like it's meant to be really small. We try and have as few things for you to learn as possible. So if you are an experienced programmer, you go, oh well, I know, oh that's that. Okay, and then you can start doing something. It's mostly a community effort, you know. I've sort of made a bunch of issues being like, it would be cool to have a cheat sheet for Go, it'd be cool to have a cheat sheet for Python, it'd be cool to have a cheat sheet for something, and then someone will turn up and goes, well, I'm a Python programmer and I've been doing Gleam for a month, I'm gonna have a crack at this, and they will make a bit of it, which has been great because I don't have the time to make these things. I mean, the flip side is that I would really love to have something which I think you have in mind, where you've got like the sort of abstract idea of a you know, a cheat sheet, and it has like these are the concepts, and then you can just flip out whichever one it is. It's a lot more free form than that. We don't have like a specification somewhere. It's mostly just sort of me eyeballing and go, yeah, that looks roughly like what's on the other one, and it's enough to get going, but it's not. Yeah, it feels like I'm just scratching the surface of how good that can be. Like so many things in these projects, I could just pour an infinite amount of time into almost any part of it.
Yeah. How's that community building effort like been for you? I mean, that's as big a part of building a language as the technical side. How have you built the community? How have you found that? And then also, I guess, like, how have you got word of Gleam out there into the community?
Yeah, I mean, I think really that's the most important bit, and the bit you should really try and get right the first time. You know, if you mess up a piece of language design, if you mess up the compiler, you can fix it. If you mess up some language design, you can release a version 2 and do some breaking changes. Hopefully not too many people be angry at you for that, but you know, you can fix it. I think if you you know, if you sour your community in some fashion, or you don't pay enough attention, it grows in a direction that you don't want it to. You know, use a really extreme example. What if a bunch of people with quite abhorrent views or racists or something just got really embedded in your community? How do you remove them? I'm not sure you can. I think you just have to make a new community somewhere else, and that's really distressing. So, you know, I think I've put. I track my hours for development time, but I don't track my hours for like community stuff. And I wouldn't be surprised if I do more time on community things than I do actually writing code. I think it's so important. And, you know, I also put a lot of time into thinking about really maybe odd things like, you know, how do we make it super clear to people that this is a community for everybody? Like, you know, I don't care what country you're from, or your gender, or your sexuality, or, you know, your taste in music, or you know, whether you think milk should go in first or second when you're making a cup of tea, you know, the really important things. And just really silly things like, you know, the Gleam branding is pink and has a sort of slightly cutesy website. I'm amazed by how impactful that has been for just making like people from the LGBT community get involved in that. Like, that's been super fantastic. There's loads of small things you can do, like how we word things and how you present things, that make it feel really cozy. And it's really worked. There's like the Discord server is just like one of the nicest places I found on the internet now. There's loads of people who just want to hang out just for the sake of for hanging out, which has been super rewarding. In terms of getting people to know about Gleam, I think I had a slight advantage in that I was very lucky in that I got into Elixir just before version 1, like just before version 1, and I was very into I was writing a lot of Ruby professionally at the time, so there's a load of things where I was like, I really wish this Ruby thing was in Elixir. So an example of that would be a linter. I really wanted a linter, so I made the first Elixir linter, and I really wanted a formatter because I was using one in Elm, maybe. This was before like Prettier really took off. So I was like, okay, well, I'm going to make an Elixir formatter, and so I made a bunch of things that other people wanted as well, and I just became like slightly known as that sort of, you know, slightly enthusiastic guy who keeps putting out these like slightly shoddy projects, but they were useful for the time. And you know, the formatter inspired the official formatter, and the linter got forked by someone else, thankfully, so I don't have to maintain it anymore, and now it's like the main linter for the ecosystem. And so I was sort of known, and when for doing these sort of like really big, weird, ambitious projects like that people don't normally do, and then when I started making another language, people sort of started to notice, like, oh, you're doing a thing, and I didn't really advertise it, but it just sort of was there, and people were mumbling. And then that made it a lot easier. I just got a lot of traction, and then mostly just word of mouth and saying the word Gleam on social media as often as I can without being banned.
Yeah, I can relate to that. And how do you see this like moving forward then? What's that? I guess what's the future of Gleam? How do you see that community evolving? How do you see the language evolving?
So we are weirdly close to something that could be a version 1 in terms of the language, which is really exciting. Feels odd. The mountain of work is now a very large hill or small mountain. I'm not sure, but we're really close to some first milestone. I'm not saying that there's gonna be a version 1 soon. I'm saying that the collection of things that we need to technically do to have a version 1 is now really small. There's this whole thing that comes after that of once you've reached version 1, you're making a statement about whether or not it's going to change. I want to put a lot of hours of use and community use into Gleam, so that if we'll collectively go, oh, that thing is rubbish, we go, okay, let's fix it before we do version 1 then. Yeah, which I don't think we're going to do, but let's have the opportunity to find those things. So that's quite exciting. There's just those few last little bits and bobs in the language, and then after that, there's going to be a huge focus on documentation and tooling and libraries. There's no point in having a lovely language if you don't have all the things that you need to be productive and make stuff. Yeah. But yeah, it's all getting getting close. Very real.
Yeah. It's nice that that's intertwining with you being able to go full time on it as well. Getting to that version 1, it just all feels like it's coming to a head at the right time for you.
Totally. And there's all this meta work of like trying to find, continue to grow the community, try and find people in the community who I can sort of place the right problem in the eye line. Yeah. And they go, ooh, that looks interesting. And they sort of burrow in that direction. We've gone from being it just me to being there's a series of people who are officially in the core team now. That doesn't mean they get anything other than they just do work for me. Well, I'd love to pay them one day, but that's not how it works yet.
It's not normally how it works with languages, is it?
No. One day, I'm hoping. Well, that's the other part of the meta problem of like I'm really trying to work out how can we get more, how can we get more money into things. I always thought it was a pipe dream to believe that I could pay my pay my bills doing this, and I've achieved that. Okay, does that mean I can also pay for somebody else's bills to work on that? Is that also achievable? Like, it would be really exciting if I could get us, much in the way that Exercism has, if I can get a small team, maybe 5 people or so, and we can actually fund everything that needs to happen. I think that would make a really good foundation for the ecosystem. So we can cover like all the language maintenance, all the compiler maintenance, all the editor tooling maintenance, and documentation, the wonderful Exercism course that we're going to have with all of our concepts exercises, and probably something like a full fat web framework sort of thing. So is that doable? I don't know.
Yeah, we'll see. It's good to have ambitious next steps, isn't it? I like it. So I'm going to just enter into the AMA stage of this. I've got a few questions. If you have questions and you'd like to ask them, please put them into one of the chats. Are you planning Gleam to target native in the future?
I really want to. I personally really want to, because I think that would be cool, and I really want to write one of those compilers. That's not a very good answer, but it's a thing where being more practical, I think there is potentially a lot of value in that, and not just because you can write command line apps, or you can do faster numerical computing stuff, but I think being able to do that. That is one of the ways that we could approach a bunch of future language editions, which I think would be really exciting and enable a bunch of things that we can't do today in Gleam. So a big limitation in Gleam is that we don't have a good way to perform compile time code execution. And there's a lot of things that we could do if we do that. So we could have something akin to a macro system, or something like, whether it be like a Lisp one, which seems less like a good fit for Gleam, or maybe something like Rust's proc macro system, or OCaml's sort of PPX type system. That could be something to explore, or a code generator like you find in C# or something. Or there's a bunch of optimizations we can do. So we've got such good static analysis in Gleam. We can tell which bits of your code have side effects and side causes, which means everything that doesn't have side effects, well, we could pre-compute those things. And so you may have things that are potentially expensive that we could just transparently make go away in Gleam, and suddenly everything gets a lot faster. So there's a bunch of things that we could enable, as well as it being just cool. So I've got to do all the things that is actually needed, I think, for the language first, like all this, final language additions and tooling and documentation, etc. But in 2040, or maybe in 2 years, I don't know, whenever I finish with this stuff and I start to have an amount of free time where I can experiment with things again, I do want to explore this sort of thing. And as the three backends I'm interested in exploring are probably native, directly native, a tiny little micro VM, which will sort of feel native, but not really, and Wasm, WebAssembly, the new magic. Those are, but it's all very much research, type things. Would be fun.
I know a great track that has a great website that has a Wasm core. Learn Wasm.
I may already be enrolled in it. I may have done some of it already.
We launched that last year. It was a great effort by a guy to put all that all together in like a 3-month intensive sprint. But so if you are interested in Wasm, we'll feature it later in the year. But it's an interesting course. So on the Exercism tracks, what's your favorite Exercism exercise?
Ooh, my favorite. I've been eyeing up the 4th one a lot lately.
Okay.
Because it looks really cool. Like someone submitted it to. I wrote a lot of the Gleam Exercism challenges, but I didn't do the 4th one. Someone contributed. I went, oh wow, that looks really fun. Yeah. And I just haven't had the time to. It's quite meaty, so I've not had the time to do it. So it's sort of been taunting me from the vicinity for a long time. I quite like Bob.
I saw.
You hit Bob really quickly, and it's weird. Yeah,
it's a great exercise. I saw Eric's implementation of Bob in Gleam earlier. I haven't looked at yours actually. I should have done. But it was one of the nicest. One of the nicest implementations of Bob I've seen in any language, which was, I think Eric said it was his favorite language he had done, his favorite exercise he had done in Gleam was Bob. But it looked really good. So I think Bob's always a favorite. It's a great, for anyone watching this, if you've not done Bob, you should be doing Bob in every language, because I think there's 2 things about it that are good. One is there's no right solution. There's a lot of different ways to approach it, especially in a language like Ruby, where you can write code in so many different ways. Like there are so many idiomatic Bob approaches that are wildly different. But I think it's often something that showcases languages, especially functional languages, quite well with pattern matching and other things. So, I enjoyed seeing Bob. Any others spring to mind? I don't want to put you on the spot too much.
I can tell you which one I don't like. I did that. I did one of these sort of ASCII true ones the other day. I've forgotten the name of it, unfortunately, and I just had off by one problem for half an hour, painful. And I couldn't. I'd subtract one and it was wrong in one way, and then I'd add one, it was wrong in a different way, and I was like, and then I just kept changing, swapping pluses for minuses, and then it eventually worked. I was like, well, I don't know what I've done. But it works now.
Some of the cipher exercises, if you get yourself into a pickle or something, it's hard to get yourself out. Back on Gleam, someone asks, what about dependent types and whole-based programming?
So
do you want to explain what those are for people first?
So dependent types are, explaining dependent types is quite hard, but I'll give it a go.
Explain whole-based programming, mate. Okay, go on. Go.
dependent types are an area of active research in sort of programming language and type computer science, I suppose, theory. And the general idea with them, which I hope I don't butcher this, is the idea that the types in your program can depend upon runtime values, which is very odd because normally
That's
types
the
happen
opposite.
earlier and runtime happens later. So you end up being able to express things where this is a function that takes in a Boolean, and if the Boolean is true, it returns an int. And if the Boolean is false, it returns a float. And it's not a union of int or floats, it is one or the other. And that sounds extremely contrived, but it's extremely powerful. You can do like the most common example of how it's useful is that you can in your program make statements about how long an array is, so you know that you won't ever index out of it. You'll always be within there. Other examples, I've seen an example in which somebody writes a regex in the program, and then I'm going to slightly butcher this. They wrote a regex in the program, and then the runtime values of the capture groups were then able to create a type based upon that. So you had like a struct that was built from this regex that gets passed in a runtime, and it was absolutely mind-blowing the stuff you can do with it. But there's a problem with it, and that problem is it's really new and really powerful, really capable, and we don't know how to use it yet, really. If you look at all the languages that have dependent types, they are very challenging. There are some projects like the wonderful Idris, which is made by Edwin Brady, I think his name is, who's a fantastic speaker, lecturer, and all-round computer science wizard. You should definitely check out his stuff. And the whole point of Idris is to say, so there's a dependent type thing. We know it's powerful. We know it's useful. How can we make it practical? How can we make it so you can easily actually write programs for these things? And Idris goes a long way to making that be the case, more so than other languages. But it's nowhere near where I want it to be for what Gleam's aims are. So I'm not trying to make a really exciting, super powerful functional language. I'm trying to make the one that enables people to do things they couldn't do before. I want the ones I want to make the one where it makes their job less stressful. I want to make the one where they get to the end of the day and like, oh, that was fun. Cool. I'm going to go about my day now, rather than, oh, I got to the end of the day. I need to go sit in front of the TV for a few hours and not think too much. And I just don't think that we know how to use dependent types well enough to get that experience yet. So no, I sadly don't get to have dependent types in Gleam.
What about whole-based programming? I don't know what whole-based programming is.
So I might. I'm going to get this wrong. I'm just going to say I'm going to get this wrong, but I think it might be a feature that Idris has in which you can do a thing in Idris where you may say you write the function head, so it has like it takes list.zip, not list, zip list takes two lists and they're of the same length, and it returns a single list of tuples of the same length, right? In Idris, you can write that type definition, and you say, okay, now search, and it will explore the search. It will explore all of the possible programs that you could have for that type, and it will give you the thing that they will have in common. So in the list zip example, it can actually just from the type annotation work out a correct implementation of that function. So Exercism would be completely stuffed for Idris because you write all the test cases, you press generate, and it just spits out the correct answer. But in more practical programming, it will just like expand, and then it will have like bits where it says, I don't know if there's a choice here. You pick one of the choices, and then I will continue. So that might be whole-based programming, or that might just be another cool Idris feature. Either way, it's really, really cool stuff.
Nice. Someone, you sort of touched on this, someone asked if you're planning to create like a Gleam Foundation with hopefully the eventual idea of hiring core devs. You've talked about the hiring bit, but is that something you're thinking of?
So the question, there's always this thing of like make a like a foundation, which kind of implies, I think it implies that you're going to make a non-profit or whatever the equivalent is in the region that you are. And I don't know if you've ever run, you probably run a business, like the whole Exercism thing. There's a lot of admin in running any form of business. Even, just from a tax point of view, it's incredibly complicated. And if you're going to make it a non-profit as well, it gets even more complicated. You've got a bunch of obligations and paperwork and bureaucracy you've got to do. And in exchange for that, you get some tax breaks. In most countries, I think, is what you get. That's what we get in the UK, where we are, right? So I don't earn anywhere near enough money for tax breaks to mean anything to me whatsoever.
I mean,
and I don't,
in the UK, so we're a not-for-profit rather than a charity. Because if you're a charity, then you can't take a salary as a director, even if you work full-time on it. So if I wouldn't be able to have a salary, which would then be a pretty bad place for Exercism. I wouldn't be able to work on it. So, and as a non-profit, we don't even get any tax breaks. We have to pay exactly the same tax as a for-profit. So, there's a lot of downsides to all of this, and often not a lot of upsides.
Yeah, so it's tricky. I think there will be a point. I hope there will be a point that comes that we are so financially successful that I go, wow, I've got a bunch of, I need to start at the money. How much detail? Okay, at the moment, I get paid personally as the developer. If it grows further, there'll point comes and says it doesn't make sense for me to be the recipient of the money. It should be a company. Now, as someone who has worked as a contract developer before, I already own a company. It would make sense for me to use that existing company because that's the smallest amount of bureaucracy for me to then be able to do the thing. And then if it continues to grow, I can then make more small incremental steps. I'm not ever sure we'll get to a point where we'd be a charity for that exact reason you've highlighted. And the non-profit stuff, we'd need to evaluate at the time whether that's worth the bureaucracy. Maybe if we find someone who does the bureaucracy, that would be actually really useful. But if it's me, the person who's best at making the compiler at the moment, probably doesn't make much sense for me to be spending my time doing spreadsheets and legal documents.
Yeah, as someone that spends a good proportion of their time doing spreadsheets and legal documents and not doing the stuff that everyone wishes I would do on Exercism, I totally agree. Cool. So, there's another question just coming in. What type system did you model Gleams off or based on?
It is algorithm W, the Hindley-Milner thing that you find in OCaml and stuff. It has a few. It's a little bit different from the OCaml one. As of fairly recently, it has a sort of generalization step similar to Haskell, in which it takes your program apart, builds a crawl graph, and then works out which order to process the functions in. So it goes from the one that is least used to the one that's most used. And if there's recursive things, it splits them to little circles and treats them as single units. I don't know if that means anything to you whatsoever, but there you go. That's the answer.
Cool. Nice. All right. So last question. What's your favorite Gleam feature? Maybe what's the bit you're most proud of in it as well as a follow on to that?
Proud and favorite are probably two different things.
Okay. Two last questions then.
We recently added a feature which I think is the most weird and powerful and fancy of all the Gleam features, and it's the newest, and as such it's my favorite because it's really fun and shiny, and that's called use. Lots of functional languages have a thing to stop. My opinion is that it's to stop nesting. I've analyzed all these fancy features people love, and it's all to stop you from writing if a big chain of things going across the screen. And they would be Haskell's monadic do syntax, F#'s computation expressions, I believe they're called, with in Elixir, all these things that allow you to write things in a flat way. But they all tend to be quite complicated in the type world. They're tied to type classes in Haskell. It has to adhere to this interface, this type class that's quite complicated and has a big scary monad word that, what does that mean attached to it? And you've got to obey a bunch of laws. What's an unlawful monad? All these things are a bit complicated. And in Gleam, we've come up with this other thing that is sort of a syntactic sugar, really, where it's going to be very difficult to explain it with words, but I'll give it a go. normally you say let A equals something, but you can also write use A equals something. And the difference is that rather than assigning a variable and then continuing with the rest of the block, what it really does is it takes the rest of the block and it turns that into an anonymous function, where the A that you have specified, so use A equals, that is the argument to the function. And then that gets passed as the final argument to the function call on the right-hand side of the equals. That sounds really weird. What does that mean? It practically means that you can have a higher order function, so a function that takes a function and write it in a flat way. So rather than saying like function name, indentation, the next function, it's all in the flat line. And yeah, we were unsure about it at first, but the more we wrote code, and we were like, oh wow, that can replace this thing. Oh wow, that can replace this thing. Oh wow, that can do this thing. Oh, that piece of code that is really ugly before, oh, it's really nice now. And suddenly just sort of everything clicked, and Gleam just became a lot prettier. It's a little unclear if you have never seen it before, and that's always going to be the trade-off with these things. But I think it was the first design I found for one of those things where I went, oh wow, that's conceptually simple enough that I think it actually fits in with the language. The error messages for it are a bit rubbish at the moment, but that's mostly because of my implementation of use and will improve in future versions. Which brings me on to the bit I'm probably most proud of. I think that the sort of developer experience, so the interface for the command line, the build tool, how easy it is to install packages, how good the error messages are, how easy to start new projects, the fact it's only one file to install it. That's the bit I'm most proud of, because I think a lot of functional languages, with an exception of like, I think Elm does pretty good at this in a lot of ways. A lot of them have, quite poor user experience. Oh, how do I add this package? Where do I find out what packages? How do I, it's all quite bad if you compare it to a lot of modern tooling in other languages. Oh no, actually Elixir does really well. Elixir is another inspiration, but a lot of languages I love are just quite unpleasant to get started with. And I think a lot of us just go, oh, it's fine, because, as you said before, survivorship bias. We've got used to it. But actually, if we started from scratch, we would go, this is rubbish. Why do we start with this?
It feels like you've done it the opposite way around. Like most languages, that stuff on at the end feels like you've really thought about that from day one as building the end at the core.
And that's why we were able to. People say, "Oh, you're going so quickly." It's like we just thought about it from the start. And so we can get it all done. I mean, the one thing I didn't think about was that language server thing, and that's causing big old problems. Like, it really does pay to think about what you want to achieve before you start.
Go back to that piece of advice you gave. Defer doing stuff for as long as possible and experiment and think for as long as possible first. Awesome. That's our time up. Thank you so much. Louis, I really enjoyed that. I apologize to everyone watching for my terrible internet connection. I think it stabilized about halfway through, but that was great fun. I hope to have you on again sometime in the future, maybe post 1.0 launch or something, and we can celebrate that together. We'll be doing more of these interviews next month. We're hoping to have people from the Rust core team and the Go core team on here. So we'll have some good interviews coming. So I'll be emailing everyone about that. But thank you for watching. Thank you.